Okay, we now look at 7.4, and this work is 7.4, and it's looking at the two major forms that lines can be placed into. The first one being y equals mx plus b form, also known as gradient-intercept form. So, just under that one, gradient-intercept form. The reason why it's called gradient-intercept form, of course, is because the formula has the formula having an m in this position just here, that's the gradient, and the intercept here on the y-axis. So when we're referring to the intercept here, it's the y-intercept. The second form that a line can be placed into here is this form here, which is called the general form. Now the general form is traditionally placing the, I'll give you an example like 3x plus 2y plus 7 equals 0. The x and the y go on the same side. So in reality what's happened is the y of the y-intercept form, of the gradient-intercept form, has been moved over to the side that the x is on. And traditionally we have the x containment term here in the front position, and then y, and then the non-x or y term equaling 0. And it has to equal 0, otherwise it's not in general form. Also, tradition has that we do put the x in front of the y, even though we often, it could actually be a negative. So we do have things like minus 2x plus 3y plus 7 equals 0. It can look slightly odd, but as I said, that's just tradition. The most important thing is it actually equals 0. Okay? Now, why would we do it? It's really no, let's go back to that one, sorry. If we take our line, I'm going to just draw any old line here. I'll just make a nice value for it. And it goes there and through that. Tweaking. Okay, so here is our line, and we're going to represent it in y equals mx plus b form. Then we know the b is the y-intercept. In this case, it's going through the origin. So if it goes to the origin, then b must equal 0. So this is equal to 0. And gradient, we make any triangle that's 3 high and 1 across, so the gradient is vertical rise and a horizontal run, so it's 3 over 1. I prefer to use it this way rather than the formula because it's much more straightforward. So the equation of this line is y equals 3x plus 0, which is just y equals 3x. If I would like to, let's rub those out. Let's take the line and we're just going to move it down. There. It's the same line, therefore it has the same gradient. So sorry, I have actually moved it slightly, so it's just not right. So the gradient, which we just found, was 3, because it's 3 high and 1 across. But this time it's going through an intercept of minus 2. So the equation is y equals 3x minus 2. And this is the most convenient form because from this you can easily read off the gradient, the steepness of the line, and the y-intercept. You also know if the line is leaning forward or it's leaning in the negative direction, because if this is a positive number, it's leaning this way. If it's negative, it's moving that way. Just one last example before we move to the general form. So let's make this lean the other direction for a bit. Form. Always get the wrong way around. No, I'm not going to do that. I'll have to go to another line. Yeah. There and okay, we'll go to a 2 and we'll also go through the other two there. Got it, right. Okay, let's work out the equation of this line. Okay, so firstly looking here, the y-intercept is 2, so b equals 2. The gradient, you can just take any point along the line. How about we just take a little triangle just here? That is 3 high, and it's 2 on the bottom of that triangle, but that vertical rise, so the vertical rise is 3, but the horizontal run is backward, so it's -2. So the gradient is 3 high and -2, so it's -3 on 2. So the equation of this line would be in y equals mx plus b form, y equals -3 on 2x plus 2. And that means that we have a fractional gradient. It's still very handy. We can read off the y-intercept as 2, and we can read off the gradient as 3 on 2, 1.5, and we also know it's sloping backward at the same time. We can also use this and find the angle, theta, because we know that theta is tan the -1 of the gradient, which is -3 on 2, and we can then work out, if we need to, the angle that it's making there with the positive direction in this direction just here. Okay, so it's very, very convenient, but sometimes we would like it to be in the general form. Now, the general form is often used when we have a fractional gradient. So let's just convert this to a general form. What we need to do is we have to have all the coefficients as whole numbers. So we're going to multiply here throughout by 2. So if we multiply throughout by 2, you get 2y equals -3x plus 4. Don't forget to multiply everything by 2. And we bring all to one side, and you bring it to the side that the x is on. So you get 0 equals -3x minus 2y plus 4. So here is the actual equation. It would be -3x minus 2y plus 4 equals 0. Now, because it equals 0, you can also multiply throughout by -1, and it will not change anything. So you would get 3x plus 2y minus 4 equals 0. These two equations are exactly equal. There's no problem with them at all. Okay, so you can have it in either form, but once again, tradition normally has it that we should lead with a positive x number. And the coefficients must be whole numbers. So A, B, and C are whole numbers, and tradition says that the A value should be a positive number. So let's do this one. If we have, let's say it's a half y equals 3/5 x plus 2, that's y equals mx plus b form. I've just added a half over here. Just to make it a little more difficult. That's, we'll rewrite that firstly by putting the y over 2, and that becomes 3x on 5 plus 2. So going from fractional form into, from coefficient form into fractional form. And this time we're going to multiply both everything by 10, because 5 times 2 is 10. That's the lowest common multiple. So you try for the lowest common multiple. So multiplying by 10, you'd get 10y on 2 equals 30x on 5 plus 20. Don't forget to do that one as well. And you get 5y equals 6x plus 20. And then we bring the y's to the x side. So we get x equals 6x plus 5, minus 5y. Minus 5y plus 20. Okay. And this meets our criterion, it equals 0, so it is in general form, and the coefficient of x is a positive number, and all the numbers that are coefficients are in whole values. If something is in x plus 2y minus 3, let's just say we have this general form, it's not as easy to read off the gradient, so we have to rearrange it into y equals mx plus b form. To do that, let's simply rearrange it to 2y, let's keep this here, and we're going to bring the x and the minus 3 to the other side, so it becomes minus x plus 3, and dividing through now by 2, And that now enables us to just be able to read off that y would equal negative a half x plus 3 on 2. So the gradient is equal to minus a half, and the y-intercept is 3 on 2. That's the quickest way of finding the gradient and the y-intercept, because it's all found in one go. Now, looking at what you need to do for your in your textbook, we've got forward here. If you would like to, just go here, you can always use this formula to find the gradient of a line which is in general form. But once again, you have to memorise this formula. So it's probably just simpler just to send it into y equals mx plus b form. So all we need to do now is, there's a long amount of work there, just to finding gradients and reading them off in both general and other weird and wonderful forms. So off you go and do 7.4. Thank you.